Hello again. You remember we got to this point where we had produced a scatter plot of the SQL Server response times, and we're about to go off and explore some of these values. So the one that interested us first was this one here. It's the highest value, 156 milliseconds, and the plot point is 29879. So what we can do is if we flick back into the spreadsheet that we produced, just let me remember that number, 29879, we flick back to here, and in here we put A29879, and that takes us straight to the point, to the row just before the point where we see the response time of 156 milliseconds. That's good, but better still, we can look here at the frame number. And now if we flick into the Wireshark trace, we can go directly to frame number 34256. So we do Control G and type in 34256, and that takes us straight to the response that had the 156 millisecond response time. Let's follow that stream, that TCP stream. We'll close that window. Now we have the response, and immediately before it we can see the request. And the request is a remote procedure call. And now let's explore that. The remote procedure call is the stored procedure prep exec. Now there are many ways of executing SQL commands, and prep exec is one of the ways. So in fact, if we look at the parameters for that stored procedure, what we should find is the actual SQL command that's being executed. So I think it will be in one of these value. There it is. So the SQL command is delete from d_status record where ID $ is in this set of values. So it's that command that experienced a 156 millisecond execution time in the server. So let's go back to our graph, to our scatter plot. Let's look again. Now I was interested in this negative value, obviously, because we shouldn't have any negative values. So let's have a look at that one. So that's plot point 27759. A27759, and sure enough we've got a -4 there. Oh, that's a bit strange because the timestamp for the request is later than the timestamp for the response, and yet the sequence numbers indicate otherwise. I think I know what's happened here, but let's just go and check 31808. So we go back to the trace, go to 31808. Because I've got it filtered. Let's change the filtered expression. Then go to 31808. And sure enough, the previous packet has got a timestamp that's later than our current packet. I'm pretty sure the reason this happened is because when I anonymized this data, I actually had to make some binary changes in the file. So my find and replace obviously wasn't all that good, and it's caused a distortion in this actual timestamp. I'm confident that's what's caused the problem anyway. So that explains our minus value, and a problem you shouldn't suffer with. If you do get minus values, then just go off and explore them in just the way I've done, and just check that the calculations have worked correctly and everything looks good. So I wanted to just go back to this chart. We see this effect here where we have multiple SQL commands or stored procedures all seeming to have very similar response times but decreasing, and all happening at the same time. Now this is a sign of, usually it's a sign that you have multiple requests have been placed on the database and they're being queued because an earlier request is holding a resource, such as a row lock or a table lock, some problem like that. And so what happens is, as soon as the first command that holds that lock completes, all of the others complete in quick succession, and you see these effects all the way through this graph. Now, because these are all happening around the less than 50 millisecond mark, these aren't really a problem. You will always get this type of short scale blocking in a database, because that's how databases work, that they have this ability to mutually lock rows and hold them for short periods of time. The only time this does become a problem, of course, is if that a SQL command or a stored procedure is holding a resource for a very long period of time. So I produced a quick mock-up of this. This isn't an actual trace, I just mocked this up to demonstrate the issue. But here you can see we seemingly have something that's held a resource for 9 seconds, and then as soon as it completes, all of the other commands that are queued up all complete in quick succession immediately afterwards, and you get this slope of decreasing response times. That's a very common feature of a blocking problem on a database. So if you're looking for blocking problems, if you can produce one of these scatter plots, it's very useful to look at it in this way. So I hope all that helps you, and I'll catch up with you soon.